Assalamualaikum. So today we're gonna present our lab assignment, which is the title is Earthquake Magnitude and Its Significance. In this video, we will explain three parts. The first part is the introduction, the second part will be the application of our study, and the last part will be the conclusion of our study. In this project, we use a dataset that contains global earthquake information between 2001 and 2022. And based on the dataset that we got, we have select magnitude of the earthquake as our variable x, while earthquake significance score as our variable y. So what is our purpose? So the purpose of our study is to determine the best quadratic curve of the data, to obtain the magnitude of the error vector, and to know the relationship between the earthquake magnitude and its significance score. In this slide, it shows the 10 points that we have selected that represent the magnitude and the significance score.
So, the real-life application of linear algebra is we can find the best fit curve to fit the chosen data using linear algebra. The first question they asks us to show that this system is inconsistent. So, what we need to do? Firstly, we have to find the fit polynomial equation to form the system of linear equation using quadratic model, which is y equals to a plus dx plus cx squared, by substitute all the point of x and y into the equation of the quadratic model. After that, we can transform it into augmented matrix so that we can solve it using ERO to determine whether this system is inconsistent or not. As you guys can see in the screen, after we solve this system using ERO until we get all the rating 1, we had the sum of false statement, which is one of them is 0 equals to negative 2568, which indicate this system has no solution. Therefore, it is inconsistent. The previous answer is we using manual calculation to answer this question. The next one, let's see how maple calculation answer this question. In maple calculation, it quite similar like manual calculation. The difference is only on ERO process, which is maple calculation using RREF rather than REF that we use in manual calculation to show that this system is inconsistent.
First, we start with the general formula for least square, which is A transpose AX equals to A transpose B. On the left side of the slide, you can see a matrix A and next to it is a matrix B. On the top right, we calculate the transpose of A multiplied by A written as A transpose A, and the transpose of A multiplied by B written as A transpose B. We also check the determinant of A transpose A, and since it is not 0, the system has a unique solution. Now, we combine them to form the normals. To start the elimination, we simplify row 1 by dividing it by 10, which gives us a leading one. Next, we eliminate the entries below that pivot. We subtract appropriate multiples of row 1 from row 2 and row 3, so the first column becomes 1, 0, 0. After those operations, we scale row 2 to make its pivot 1, then use row 2 to eliminate the entry in row 3's second column. Now, the matrix shows a 1 in the second pivot and 0 beneath it. Finally, we scale row 3 to make the third pivot 1. Last step, we interpret the triangular system as a 3 simultaneous equation. Substitute C 49.405390 into equation 2 to solve for B. That gives B equals to negative 478.175253. Then substitute for B and C back into equation 1 to solve for A. Yielding A, we got 1681.4726. Putting the coefficients into the quadratic model, which is y equals to a plus bx plus cx squared, we obtain the best fit quadratic is y equals to 1681.4726 minus 478.1753x plus 49.4054x squared. Here, Maple forms the augmented matrix A transpose A and a transpose B. Then, using the command reduce row echelon form, Maple performs all the row operations optimally. The output gives us the final row reduced matrix from which we can read the values from A, B, and C. So we got A equals to 1681.5867, B negative 478.2067, C 49.4075. So the best quadratic curve equation is 1681.5876 negative 478.2067x plus 49.4075x squared. This confirms that our manual calculations were correct. Here is the graph generated from Maple using the least square quadratic model. The dots represent our original data points and the smooth curve is the quadratic equation Maple produced. We can see that the curve fits the data very well, showing a clear increasing trend. This confirms that our least square approximation is accurate and appropriate for the data.
So, I will continue with the error vector and magnitude of error. In manual calculation, we have two parts. The first part is we need to find the error vector, and the formula is equal E equal to B minus AX. Then we need to arrange all the value. Same goes with the formula to get the value, 10 value in matrix form, 10 by 1. So for the second part, we need to calculate the magnitudes of error vector. The first thing first, we need to find the summations of E squared. So 10 value that we get above, we need to square each of them and then we need to sum all of them. So we will get 386.013894 and then we need to square root the value so that we can get the value of magnitude of error vector equal to 19.6472. So let's move to the Maple calculation. Here we want to combine is it the value in manual calculation and Maple calculation are the same. So as you can see in step 1, 2 and 3, the black code is the code that we write in the Maple to find the value of error vector. So in the step 4, we want to calculate the magnitudes of error vector. After we write the code and then we will get the value.
Finally, we have come to our conclusion part. We have successfully obtained the best quadratic curve using both manual calculations and Maple calculation. The value that we got were consistent, therefore confirming the accuracy of our implementation. So, this is the comparison of the manual calculation and Maple calculation. In this part, we have three things that we compare, which is the first one is the quadratic equation, the second one is the error vector, and the last one will be the value of the magnitude of the error vector.